Alright, now we're going to talk about the product and quotient rules for derivatives. And very important that you get on the right foot here. In these rules, u and v are representing functions of x. So where you see u, you see v, that could be some type of expression, something bigger than just a single variable. So the product rule is for when two things are multiplied together, u times v. So that would be two things that you probably have a rule for individually, but not collectively, and the product rule lets you handle that. So the product rule derivative of u times v would be v times u prime plus u times v prime. Okay, and because multiplication and addition can be interchanged in ways, you can mess this up a little bit, or at least change this order somewhat and be okay. Now the quotient rule is for when two things are divided, u divided by v, which is usually means you would understand how to take the derivative of u and the derivative of v separately, but maybe it makes something a little bit more interesting when you put them together. Now here the order is very important. So derivative of this would be a numerator v times u prime minus u times v prime over a denominator of v squared. Okay, so because subtraction and division are important as far as order, if you change the order of two things subtracted, you get a different answer. You don't want to mess that up. Okay, so let's see how these are used. First of all, the product rule here. So what we have here is we have y equals e to the x, and that's times 4x cubed. Now we don't have a rule for this thing specifically, but if we look at it as u being e to the x and v being 4x cubed, it's two things multiplied together. We know how to take the derivative of each one of those things. U to the x, when we take the derivative of u prime, will be just, e to the x. Derivative of e to the x is e to the x. And then for the v, 4x cubed, v prime, the derivative will be 12x squared. So the derivative of the original function will be v times u prime, so that would be 4x cubed times e to the x, so that's v times u prime, plus u, which was e to the x, times v prime, 12x squared. And we can clean that up as far as making it look neater, or combining like terms, or multiplying out coefficients, but you should see what we did here. Okay. The second one here is f of x equals the natural log of x, and that's all times the polynomial 5x cubed plus 9x minus 2. So in that case, we can let u be natural log of x, and we can let v be 5x cubed plus 9x minus 2. Okay. And then we'll need a derivative of each one. So derivative of u prime, derivative of natural log of x is 1 over x. And v, derivative of 5x cubed plus 9x minus 2 will be 15x squared plus 9. So from there we will go ahead and build our derivative by placing those parts together. So we will have f prime for our derivative, okay? V, which will be 5x cubed plus 9x minus 2, times u prime, which will be 1 over x, plus u, natural log of x, times v prime, 15x squared plus 9. So here we have v, u prime, u, v prime. And all that works together to give us our nice little derivative. Okay. Now let's try the same thing with the quotient rule. So write it down, because it's going to disappear off the video when we get down here a little bit. So number 3, we have f of x equals the fraction numerator 7x plus natural log of x. That's going to be our u. And on the bottom we have e to the x, which will be our v. So let's write those down. u equals 7x plus natural log of x, v equals e to the x. Okay. And then we're going to find their derivatives. So u prime, the derivative of 7x is 7, plus the derivative of natural log of x is 1 over x. And then v, e to the x, derivative of that, v prime will be e to the x. So now we're building a fraction, and order is very important. So v times u prime minus u times v prime all over v squared. That's the original v squared. So that gives me e to the x times the quantity 7 plus 1 over x. That is my v times u prime. Let me put that in here. V u prime minus the quantity 7x plus natural log of x. That's my u times e to the x. That's a v prime. All over the original v squared, which was e to the x squared. Okay. I understand the quotient rule can get rather large, but it's our tool for handling things that are a little bit out of control. The next one, number 4, y equals a numerator 4 to the x minus 7e to the x over denominator of 6x plus 4. So my numerator 4x minus 7e to the x. Let's see what that looks like. So that's my u, 4 to the x minus 7e to the x. So u prime, 4 to the x derivative is 4 to the x times natural log of 4. And then minus derivative of 7e to the x is 7e to the x. Okay. And then the v part of this, 6x plus 4, that one will be a little bit easier. So if v is 6x plus 4, then v prime is just 6. So derivatives, put it all together. Hope we got some room here. Derivative v, okay, y prime is v, so 6x plus 4 times u prime. That's 4 to the x times natural log of x minus 7e to the x minus u, 4x minus 7e to the x. Come on, buddy, you can handle this. Times 6. And that'll be all over v squared. So 6x plus 4 squared. So in all the parts that we've got here, we've got v times u prime minus u times v prime that wants to disappear all over v squared. So we'll try and put this back over here. It just doesn't want to write over here. It'll let me write sometimes. Let's see. We'll just leave that alone. Thank you.